All right, let's do the 2022 exam now. So these are just the logarithm questions. So our first question is solve the equation 2 to the x equals 2022. Okay, well, that's nice. They're all the 2's. So the x is up in the exponential. So let's sort of take log 10, I guess, of 2 is going to be equal to log 10 of 2022. So therefore x must be equal to log, and I'm going to get rid of the base there because it's log 10 over log of 2. And then we go to the calculator. So log of 2022 is that, divide that by log of 2, and we get 10.982. GDP. Yeah, let's move on. Okay, simplify the following equation fully, writing your answer as a simple logarithm. Okay. So we've got 2 logarithms added, and when we add them, we can when we combine them, we multiply what's in the brackets. But the complicating factor, I guess, is this 2 out the front here, but exactly the same as we did in this question here. We can square it. So let's take that to the power of 6 squared, and it's going to be a squared over 36. And we've got rid of that. So let's rewrite that. Log of 3a plus log of a squared over 36. And when we combine the logs, that's going to be log of 3a times a squared over 36, which is going to be log of 3a cubed over 36, which is going to be log of a cubed over 12, isn't it? Yeah, 12. We cannot move that 3 out, so that stays there. I think that's as simple as it's going to get. Yeah, okay. So the thing which is complicating there is the 2. You need to get rid of that 2 first before you can combine them. So you cannot say, for example, let's change the, you cannot say 2 log 3a times a over 6. You can't do that. You've got to get rid of that 2 first. Okay. All right, consider the equation log base 2x minus 1 minus, okay, so log 2x plus a equals c, where a and c are constants. I think I call this a1, but it's an a. A and c are constants. Okay, cool. So they're, in other words, they're real numbers as well. So solve that when x is made the subject of the equation. X equals this. So we want to solve for x, make x the subject, and then get it in that form. So these are both the same base. So we can use our rules to rewrite it like this. X plus a. And it's going to be equal to c. So let's raise both to the power of 2. So in other words, 2 to the power of that equals 2 to the power of that. And we get x minus a over x plus a, I don't know why I put it in brackets, equals 2 to the power of c. Right? Does that help? Let's have a look. So let's move this down because I think I'm going to need more room to do this. Let's bring the denominator over the other side. So x minus a is going to be equal to 2c x plus a. We're making x a subject. So let's expand this out here. So 2c of x plus 2c of a. And let's bring all the x's over one side. So x minus 2c of x is going to be equal to 2c of a plus a. So I brought that a over. And we want to make x a subject. So let's factor out the x on this side. 1 minus 2c. The original equation had an a out here by itself, so let's factor out the a. And that looks promising. That's already in the form that we want. Yep. Which is same as a 1 plus 2c, since it's in the same order that they give up here. Okay. Is that done? So then we want to divide across. So at the moment we've got x1 minus 2c equals a 1 plus 2c. Let's divide both sides over. X equals a 1 plus 2c over 1 minus 2c. Now, is that already in the form that we want? Plus, minus, yes it is. So we can just bring that a in front the way that they have it in the question. Ah, there you go. Good algebra question, actually. Yeah. Right, we're back. This question. The equation log base 2 x plus x minus a minus log 2 base x plus a equals c is only possible to solve for some values of a and c. Okay, explaining your reasoning clearly, describe the values of a and c which will make the equation possible to solve. So remember that a and c are both constants. You may find it useful to recall that when x is made the subject, x equals this. Okay. So let's eliminate what a and c cannot be. So when we look at this bit, 1 minus 2c cannot equal 0. So when we solve that, 1 cannot equal 2c, so therefore c cannot be equal to 0, because remember 2 to the power of 0 is 1. So c cannot equal 0. All right. Let's have a look at these two here. So remember, you cannot take a log of 0 or a negative number. So log of 0 or less, you cannot be done. Okay, it's math here. Well, it can't be done with real numbers. So therefore, x minus a must be greater than, or no, just strictly greater than 0. So it follows therefore that x must be greater than a. Okay. And then on the other side, x plus a must be greater than 0. So x must be greater than negative a. Okay. So that's 3 conditions that are met. Now let's look at C. So A is intriguing there. So A, let's see what happens when A equals 0. What would happen? So if A equals 0, x would equal 0 as well. Live up here, but x must be strictly greater than a, so that can't happen. But also if a equals 0, then log 2 of x minus 0 minus log 2 x minus 0 would be equal to c. So that minus that is 0, so c would equal 0, and we know from here that that can't happen. So therefore a cannot equal 0 either. Yeah, that makes sense. Okay. Now let's have a look at what would happen if a was greater than 0. And let's take this one here. So therefore, if x must be greater than 0, then a 1 plus 2 to the c would have to be greater than a. I think that works. Yeah, I think that would probably work. Hang on, I'm just going to think about this. Yeah, that would work. The reason being is we know that x is greater than a. So if a 1 plus 2 to the c over 1 minus 2 to the c is greater than x, therefore this must be greater than a. Okay. So that means that we can cancel out this a. We can divide both sides by a. And because a is greater than 0, that means we can do that because we're not dividing by a negative number. So 1 plus 2c, 1 minus 2c must be greater than 1. And we want it greater than 0. Okay, so let's take 1 away from both sides. Move that up a bit. So 1 plus 2 to the c, 1 minus 2 to the c minus 1 must be greater than 0. Okay, well, we want this over a common denominator, and I'm going to do a conjugate multiplication. So 1 is going to be equal to 1 minus 2c over 1 minus 2c. So we've got 1 plus 2c minus 1 minus 2c over 1 minus 2 to the c, and that's got to be greater than 0. And that means that the ones will cancel. So we've got 2 times 2 to the c. It's not 4 to the c, because we don't know what c is, over 1 minus 2c. Now 2 times 2c must be greater than 0, because if c is greater than 0, this would be a positive number. If c equals 0, which can't happen, that would also be greater than 0. And if c was less than 0, 2 times 2 to the, say, half, minus 2, that's also going to be a positive number. So that's got to be a positive number. So therefore, the only way that can be true is if c is less than 0. So c would need to be a negative number, because we can't have that cannot exist. Because the net would need to be positive as well. So 1, I'm thinking this through. So this needs to be positive. So that's got to be positive. That would have to be positive. So 1 minus 2c would also have to be greater than 0. So 1 would have to be greater than 2c, and the only way that would be possible is for c to be less than 0. Yes, that makes sense. Yes. So there's another condition. So if a is greater than 0, c must be less than 0. Okay. So that does it for c as well. And let's look at the other alternative. So a is less than 0. That would mean that the numerator and the denominator would have to be opposite signs. So one minus 2c, 2 to the c, would have to be a negative number, would have to be less than 0. So that means that 1, not 2 squared, 2c, 1 would have to be greater than 2c. 1 would have to be less than 2c. And the only way that could be possible is for c to be greater than 0. Because if c equals 0, we can't do it anyway, because that would be 1 equals 1, so that wouldn't be true. That equation wouldn't hold. And then if c was less than 0, this number here would be a fraction, which is less than 1, so c would have to be positive. So our conditions now solved. So a cannot equal 0. We found that. C cannot equal 0. We know from before x must be greater than a, x must be greater than negative a. Okay, and we know that when c is greater than 0, a must be less than 0, and when c is less than 0, a must be greater than 0. That's the only way that can work. yeah, I think that's it.